chemistry concept videos. Earlier video we saw about the isomerism in the compounds. So isomerism, positional isomerism, chain length isomerism and functional isomerism and even metamers we discussed. So all these isomerism are considered to be structural isomerism. Why they are called as structural isomerism? Because the structure of the carbon itself or the structure and the position of the functional group itself will have a change. But sometimes some isomerism which is having the same molecular formula as well as the same structural formula also, but it may also be considered as some isomerism. So what type of isomerism that is? That is called the stereoisomerism. In stereoisomerism, the molecule will have the same molecular formula and the same structural formula even, but there will be some change in mode of arrangement in three-dimensional space. So stereoisomerism is broadly classified into two main types, and that is, one is configurational isomerism, the other is conformational isomerism. So here we are going to check about the conformational isomerism and its types. So conformational isomerism can be studied in sp3 hybridized carbon, for example ethane. So here we are having the conformational isomerism of ethane, simple ethane. Why conformational isomerism for ethane is studied? So because ethane is having a carbon-carbon single bond, there will be a rotation in the carbon-carbon single bond. Due to this rotation, the different mode of arrangement in the three-dimensional space can be explained in this conformations. Okay, so that is called as conformational isomers. And here I am going to take another example and explore you about what is the different types of mode of conformational isomer we can be able to find with respect to the CC single bond. So carbon-carbon single bond, it is having a free rotation. Due to the free rotation, we are having different conformations or different three-dimensional spatial arrangement, that is called as conformational isomerism. And the first denotion, this is Saha's formula. In this Saha's formula, both the carbon atom will not be hindered and both the carbon atom will be showcased, and their normal bonds of all the carbons will be showcased in this Saha's formula. So better to this Saha's formula, Newman projection formula, and this Newman projection formula will be easier to draw the conformational isomer. Using the Newman projection formula, I will elaborate the conformations of butane. So this is butane, and here we are having 4 carbon atom, the one CH3 group. I am going to elaborate by using this carbon-carbon single bond. Using this carbon-carbon single bond and Newman projection formula, here I am drawing the carbon bonds of the first carbon, and the next carbon will be hindered backside to this. So first carbon is having CH3 and 2 hydrogen. So I have written CH3 and both are hydrogen. The next carbon, it will have, and the carbon is actually hindered backside to this, it have a CH3 group, and similarly a hydrogen, and similarly a hydrogen next to this. And here we can be able to draw different orientations. It's like this. And similarly one more rotation, and actually what happens in the sense, the CC single bond, this carbon and carbon single bond, I am going to take this bond and this bond with respect to this single bond, and this single bond rotation we are going to notice here. Here this carbon and the CH3 carbon, that is bulkier carbon, both are overlapping each other, both are one over other. So the degree of rotation here is 0 degree. When this is tilted to some angle, when it is tilted to some angle, that is mean 60 degrees, and we will get this conformation. And once again I am tilting this angle to another 60 degree. I will get this conformation. So the bond angle of rotation is 120 degree. And again I I am rotating with respect to the CC single bond. I will get a bond angle like this. The angle of rotation will be like this. The angle of rotation here is 180 degree. And again I am rotating on the either side, it will become the same molecule is like this. So here we are having totally 6 conformers. One is fully eclipsed. This is called fully eclipsed conformation. And another is staggered. That means splitted pattern, staggered, and this is called fully staggered conformation. This is fully eclipsed conformation and this is fully staggered conformation. On the other hand, this CH3, if it comes to this position, will have 2 conformers. Will have 2 conformers, and when this CH3 comes to this position, then we'll have another 2 conformers. So total conformations we are having: one fully eclipsed and one fully staggered, and 2 partially eclipsed conformation and 2 partially staggered conformation. This is partially staggered conformation, partially staggered, and this is fully staggered conformation. So total conformations for normal butane is 6. So normal butanes are having 6 conformers.